Recording in progress.
Okay, so as I said, today we want to look at time management under project management. Okay, so last Tuesday when we met in class, we looked at the time and we used it to calculate we did the forward and the backwards path. We looked at the critical path. Then we also did a whole lot, right? So today I want us to take this example and use this example to do our Gantt chart. Okay, so we have this table here, and let me do this here. All right, so I hope it is okay now. Please, I hope you can see my screen, or it's too small. The way I've made the screen, is it too small? Please, can you hear me? The one who has raised the hand. Please, I said if you have any question, go to the chat and put your question over there. Some are saying it's okay, some are saying it's too small. Well, we'll take the it's okay part because the left. Oh, this is I need enough space. Okay, you don't worry. Let me do it this way. So our question is for us to. Yes, you can respond because I said if you have anything to say, go to the chat. If you have any question, go to the chat and put your question there. All right, so we are looking at project management, and today our main focus is going to be on the drawing of the what do you call it? Okay, so we want to look at how. Okay, somebody's also saying you already have the slides. So if you already have the slides, then I can just minimize it and do what I have to do on the screen because I need the full space here to work. All right, no problem. You let it be there so that we can all look at it as we. Oh no, Tindana, don't worry, you type because if I allow people to talk, there will be a lot of distraction in the class. So please, let's do it. So we want to handle this question here. The question says, sketch the network described in the table. So if you look at it, I've told you that anytime you are given an example like this, the first thing you should be looking at is which one is the predecessor and which one is a successor activity. I hope you remember. So anytime you are asked to sketch a network, the first thing you need to look at is which one is the predecessor and which one is a successor. So fortunately for us, in this very example, we have been given a column showing the various tasks. So our tasks are the various successors and their corresponding predecessors. Is that okay? And for this very example, as I said in class the last time, we are lucky that we have been given the time. So we are not supposed to calculate the time. And if you remember in class, when we were calculating time, the time estimation, somebody said I should take you through the time. The time estimation, we used to calculate it as time estimation is equal to alpha A, which is the optimistic time plus 4M. And the M is the most likely time plus the pessimistic time, which is B. And in certain books, the optimistic is denoted with O, and the pessimistic is denoted with P. So if it is, you can either write it A, you can either write it A plus 4M plus B over 6, or it can be O plus 4M plus P all over 6. It depends on which book you are using. Okay, so this shouldn't be anything so difficult. So what we did was that we just inserted the figures. So our first example from last week, if you remember very well, last Monday, this was the table. Our optimistic time was 7. Our optimistic time was 7 plus 4 into bracket M. And our M, as I explained in class, is 8 here. So 8 plus our pessimistic time, which is 15. Okay, 15, all over 6. And if you do it, you should get 9. Okay, if you do the maths, you should get 9. And that was how we got the activity Z, the duration. So if in examination, if you are given a table like this, you have to draw the table, okay, and you indicate time estimation. This will be 9, and I think this was 18 or so, and you indicate the various times of the various durations over here in examination if anything of that sort should happen. But today we are not going to do calculation, but we are rather going to do critical path to use it to learn how to use the Gantt charts. Okay, so let's quickly go into our let's go to our table for today. So this is our table, and we are supposed to draw the network diagram. Please, just a second. Just a second. Okay, so we want to, as I said, we want to look at the network, draw the network diagram for this very example. So if you look at the example, we have activity A all the way to K. So A, B, C, D, E, F, G, H, and K. And their respective time are over here. So we don't need to calculate the time duration because already we know the time duration of each of these activities. So we start with activity A because it is the starting activity which has no so you have activity A here which has no predecessor. So Tindana, I don't know why you still want me to unmute all of you. Please, let's do it. When it gets to time for me to unmute all of you, I'll do that. But I have done this over and over, and I know how students behave. So let's continue. As I said, if you have any question, just put it at the what do you call it? The comment section, and I'm looking at it. So activity A is for we are done with activity A, and the duration is 4 days. So I'll put the 4 days here. Please, you can be sketching it along, because we have done it in class, so you should know how to do some of these things. Activity B, if you look at the predecessor here, A is the predecessor to both B and C. So it means there's going to be what? There's going to be what? So there is going to be a best. So we have. So you can be sketching it along, because we have done it in class. So this is activity B. This is activity C. Now, if you look at activity D and E, okay, they are also all coming out of activity B. So it means activity B also will bring out another best. And once again, as I said, the arrows are very, very, very important. So activity B is bringing out D and E. And let's not forget to add the time duration. So for activity B is 9, activity C is 11, activity D is 5, activity E is 3. Okay. Then we have F, which is also coming out of C. Okay. We have F. So we have activity F. Activity F coming out of C. Then we have activity G coming out of D and F. So let me do this. Let me do this here. Let me put D here. Let me put D here. And let me put F here. E. Let me put E here. So the time estimation for E is 3. Activity D is 5. So we have the next one, activity G, which is coming out of activity G, which is coming out of D and F. So we have, there's going to be a merge. So this is activity G. So F is 7, G is 3. Then activity H. Activity H is as a result of E and G. So we have H. So E and G. So this is H, and H will give us activity K. And all of them, we need to indicate their time duration. So H is 2 and K is 1. I hope if you sketch your diagram very well, you should be having something similar like this. Okay, any questions so far? You can't see what I've drawn on the board. I have my figures already, so there will not be any need for me to put it. Yes, it's possible. Somebody said, we draw without changing D and E. Yes, if the line crosses, that is fine. But the rules of drawing the network diagram is that as much as possible, if you can do it such that they will not cross, that will be the best. But if it crosses, nothing, there shouldn't be a problem. I had the liberty to erase or to clean and draw it again. That is why I did it that way. So if you have to, if your line has to cross, for instance, if E was supposed to be here, if E was supposed to be here and D was here, this one would have crossed a line here, which is still fine. So there's nothing wrong with what you did, okay? Aye, Daniel. All right. Now, let's indicate their various time durations, okay? So the next major activity that we need to do is to look at their expected starting time and their expected completion time. Okay, so let me go back to my red pen. Okay, let me use a different color for this. Let me use green. Okay, let me use green. Probably will be better. So let's go. We are saying that all activity begins on day 0. So we are doing our forward pass. Please, I hope you are following. We are doing, if you don't have the slides, contact your course rep. We are doing the forward pass and we are saying all activity begins on day 0. So day 0, and the rule says to find the early finish, it is early start plus duration. So this will give us 4 here. And this 4 is destined to give us these 2 activities, B and C. So definitely this early start of this activity is going to be 4. This early activity is going to be 4. Then to find the early finish, it's going to be 4 plus 9, which will give us 13. And don't worry, just follow me here. We have finished drawing the diagram. So just follow me here. So 4 plus 11, this will give us 15. Now, this activity B is destined to give us these 2 activities, E and D. And definitely is going to be their early start. So 13 here and 13 here. You are saying you can't read the slides. I've given you you have the slides all this while. So these rules, you should be able to, you should know them by now. If you practice it, you should know them by now. So this will give us 16 and this will give us 18. This is just one activity. So this will give us 15. And 15 plus 7 will give us 22. This activity is linked up to this, and this activity H is linked up to G and E, but we should be able to calculate G before we be able to find its early start. So this is 18, this is 22, and the rule says when we are doing a forward pass, we pick the highest. So 22 will be here. So 22 plus 3 will give us 25. And now for activity H, because we have 16 and 25 coming here, it means we'll pick the highest, which is 25. And this will give us 27. And 27 will be here. 27 plus 1 will give us 28. So in all, the entire project duration, or the project is expected to complete in 28 days. Okay. The project duration is supposed to complete in 28 days. Assuming this example is talking about days. If it is no weeks and it is days, then that is it. All right, so let's do our backwards pass. A backward pass. So our we have done our forward pass. We are doing our back pass. So this is 28 here. Okay, let me use a different color for this one too, so that it doesn't mix up. Okay, let me use mauve. Okay. So we have 28 here, and we said the backward pass rule. The backwards, we said it's a subtractive move. I hope you remember. It's a subtractive move. So we are going to subtract the duration from the late finish. So 28 minus 1 will give us 27. Then our late start is going to be, when we are doing the backwards pass, our late start is going to be our late finish here. So 27. 27 minus 2 will give us 25. Then this 25, because it is giving a best over here, because we are doing a backwards pass. So 25 will be here, and 25 will be here. So 25 minus 3 will give us 22. 25 minus 3 here. 25 minus 3 here will give us, let me see, activity E. So this will give us 23. So this one, there's a best. If you are coming from the back, there's a best. So 22 will be here. 20, then 22 will be here. Okay. So 22 minus 7. E is 20. Somebody say E is 22. Okay, good. 22. Thank you very much. Edward, thank you. So 22 minus 7 should give us 15 here. 22 minus 5 should give us 70, right? 17. So now this will be 15 here. And when we are doing a backwards pass, we choose the lowest. So between E and D for activity B, we'll choose the lowest, which is 17. So 17 here. So 15 minus 11, this will give us 4. 17 minus 9 should give us is it 8? Okay, then when we are doing the backwards pass to this 2, 4 and 8, we'll choose 4, the lowest. Then 4 minus 4 will give us 0. Any questions so far? So let's calculate the float to find our critical part. So float for activity A is 0. Float for activity B is 4. Float here is equal to 0. Float here, there's not enough space here, so I'm just putting it up here. Okay, so float here, 25 minus 16, this should give us 9. D, activity D should give us 4. F is equal to 4. This F should give us 0. This F should give us 0. F is equal to 0. F is equal to 0. So we now want to look at the various paths. So the first path is, I'm going to use a yellow pen to Sally Ampim say, I don't understand the float. The float is if you subtract, you just the early start and the early the late start. The early start minus late start, early finish minus late finish. So we subtract the bottom here from the top. And it doesn't matter. So for instance, this one, if you are going to subtract 17 from 13, we are not going to, you can't say -4. Okay. It's just a matter of finding the difference between the figures. Okay. And if you do it and you realize that something is not matching up, assuming we had 5 here, we have 4 here, that means your math was very bad. Sir, please, why is late finish for F is 25? It is 25 because F is, okay, late finish of F is not 25. Late finish of F here, F is 22. Victoria Anderson. You are saying, sir, please, why if late finish for F is 25? F late finish, this is late finish of F is 22, not 25. So please. So let's look at the various paths. I'm going to use a different color to indicate the path. So we have A, we can go through this path here. Let me use a marker. So we have A, B, E, H, K. We have A, B, D, J, H, K. We have A, B, no, we have A, C, F, G, H, K. So let's see. Oh. So A, we have A, we have B, we have E, we have H. Please, I hope the yellow color is okay. You can see it. And K. Please, I hope the yellow is okay. A, okay. So A, we have B. Those who are asking such questions, I'm sure those are the people that didn't come to class, or when they came to class, they were talking. D, then we come to G. Then we come to H. Then we come to K. So A, B, D, G, H, K is one part. Then we can have A, C, F, G, H, and K. All right. So I don't know if there is any other part that I've not seen it. You can draw my attention. Is there any other part that I've not indicated? So let's indicate their various floats. So A is 0, B is 4, E, the E float for E is 9. Float for H is 0. Float for K is 0. Now, this part 2, A is 0, B is 4, then D is also 4. Okay, Edward, thank you. So G, the float for G is 0, H is 0, and K is 0. A is 0, C is 0, F is 0, G is 0, H is 0, and K is 0. So what it means is that if we want to look at the floats for each of these paths, floats for the first part is 9, float for this part is 8, and float for this part is 0. So definitely this becomes our critical path. And the rest, these two are feeder paths. The first part is 13. Sorry, because there's 4. Sorry. So 13. Okay, thank you very much. Thank you. Grace and Co. Thank you. So we are able to boldly say that this is our critical part because the definition for critical part says that the part with the 0 float or the part with the least float or the longest path. And if, for instance, let's do one thing over here to confirm. Let's put the various time durations in each of these activity. So for instance, activity A is will last for 4. If it's in days, will last for 4 days. Activity B will last for 9 days. Activity C, E will last for 3 days. Activity H will last for 2 days, and K will last for 1 day. A 4, B 9, D will last for 5 days. Activity G will last for 3 days. Activity H will last for 2 days, and activity K will last for 1 day. Activity A 4, C 11, F 7, G 3, H 2, K 1. So let's do the total. Let's do total. So 4 plus 9 Plus 3. 0 plus 9 plus 3 plus 2 plus 1. What will be the answer? I'm not using a calculator. So those of you who are with your calculators, help me out. Somebody said 19. So this is 19. This should be 24, right? 23 or 24. Edward, 24. Check your maths very well. And this will give us 28. So it still confirms that that path is our critical path, because we said critical path is the longest path. Okay, so it still confirms that A, C, F, G, H, and K is our critical path. So let me use a marker to show this to this to that to that to that is our critical path. Any questions so far? Please, any question? Benedicta, please go and type. If I want everybody to talk, okay, let me give chance for maybe 2 questions. So if you have a question, just raise your hand. Let me unmute you to talk. If you have a question, raise your hand. I will mute you so that you can be able to ask your question. Any question? Okay. It means everybody. One hand. Who is that? Benedicta. Benedicta, your line is very bad. I can't hear you.
I'm asking to be a situation that there will be no critical path.
The line is breaking. So please type your question and let me see if I can help you out. I can't hear anything. I don't know if the rest could hear you. Please, can you hear her? Me, I couldn't hear her. So Mercy said no. Everybody said no, we can't hear you. So Benedicta, please go and type your question and I'll address your question. So quickly, without wasting much time, let's look at the Gantt chart. And you see, the reason why we use the critical path, the reason why would there be a situation where there is no critical path? Definitely there will always be a critical path. We are saying that the definition of the critical path is that, Benedicta, listen to me very well. The definition of the critical path is that it is the path with 0 floats. That is number 1. Or the path with the least floats. So for instance, assuming we didn't get 0 and there was 8, assuming this is 10, assuming the float for this path wasn't 0, but it was 10, then we'll choose the one with the least float, which would have been this path. Okay, so the definition of the critical path is the path with the least float, or the 0 float, or the longest path among the various paths that we are able to identify. All right, thank you very much. Now, the reason why we calculate the critical path is that to be able to draw your Gantt charts, we are going to use the same data to do our Gantt charts. To be able to draw your Gantt charts, you need the number of days to be able to draw your Gantt charts. Somebody say, what if there is a draw? What do you mean by a draw? You can have 2 parts being the critical, because if all of them are having the same figure, then because the most important thing is that the critical part is just supposed to tell you how many days or the actual time estimation for you to be able to finish the project. Okay. Now let's go to our critical path. Aye, Daniel, I don't understand your question very well. Let me raise your hand. Let me unmute you so that you ask me if I can be able to help. Raise your hand. Let me see if I can unmute you. Aye, Daniel. Aye. Okay. Please, let's continue. I think we should continue because we have a lot of things to do. Oh no, I Daniel, you should Dominic Yaboa, the question you are asking me, you should know what this answer is. You are saying the first question we solved, the critical part was down, and that this one to the critical part is down. No. It doesn't matter because we decided to do it. We didn't know which one was going to be our critical part until we indicated the various items over there. That's when we realized that was our critical part down there. It's not a rule. Okay. Hi, Daniel. Let me see if I can be able to help you out here. Hi, you have unmuted yourself. Talk. Let me listen.
Sir, please. What I'm saying is, can we also derive the critical part by saying the activities with the
activities with
early
what?
finish and the late finish when the days are the same. Can we also the activities with the same number of days, the early finish and the late finish?
Those are the activities that are with zero floats. You see, all those with the zero float have the same early start, early finish, late start, late finish. And those are the activities on the zero float. So those are the ones that usually end up being on the critical path. I hope you're with me.
Yeah.
All right. Okay. Thank you. So let's move on and do our Gantt charts. I'm going to do the Gantt chart up here. Okay. So this is how you do the Gantt charts. You okay. So for this question, we had activity A. Sorry, let me bring it a little bit down. Let me bring it down.